We wanted to talk to you a little bit more about the registration and why it's so good on our Linoprint digital presses. I'll use this as an example. Here we have 18-point C1S, okay, folding carton sample. You can imagine that instead of doing a long run on a press, we only want to do 50 of these. The challenge that we've had in the past is that the registration was not good enough from sheet to sheet on a digital press. So when we went to go die cut this, we got to hit the die lines, right? And the die cutter, it cannot adjust for sheet to sheet registration variants. Okay, so now we have excellent performance on both the Linoprint CV and CP. Previously in digital presses, especially in a very cost-effective digital presses, I mean, you had to spend over $500,000 in order to get registration performance that would satisfy the needs of this kind of an application. Okay? And often customers didn't have enough volume in order to fill up a press that costs that much, and so it was difficult for them to be profitable, with their digital work. Okay? The great thing is, in much more cost-effective solutions here with the Linoprint CV and CP, now the performance is absolutely excellent. And the reason for that is that in the Linoprint CV and CP, as opposed to mechanical registration, it's very static mechanical registration. Now where we are using a control system, we are actively registering the sheet. When the sheet comes out of feeding, and we have vacuum feeding now, okay, so the sheet is actually coming out very reliably and very straight to begin with, which gets us well on our way to better performance to start. So we're not coming out skewed, okay, so we come out very good just out of the gate, okay. We have actually servo motors or stepper motors on the back of our registration system. So as the sheet comes in, it actually hits a roller in the registration system, and in the CP it actually hits sheet stops, okay? And at that point, we are detecting a few things of the sheet. One, we're detecting if the sheet is skewed, and what you do is we will square up the sheet before it goes into transfer, okay? Then we're also looking for the X direction and the Y direction of our registration. If the sheet is in the wrong position coming in, the system will actually take the sheet and it will move it in the X direction or operator drive side direction, so it goes into transfer from sheet to sheet and make sure that it is in the right position. Okay. The other challenge of digital presses is, we go through fusing, and the sheet changes its dimension actually after it goes through fusing, so front side to back side registration was also a challenge. Okay. Using our system as well too, we have the ability to dial in the sheet, okay? The actual operator will dial in the sheet, and they will save that parameter with the media profile, okay? So the next time we want to run this substrate, we just put it back in and we don't have to dial it in again. But what it's actually looking for is it comes around back through, and if the sheet is actually early or late, it will actually adjust the speed going into transfer, okay? And we will actually compensate for that sheet stretch or that sheet shrinkage, okay? Okay, from front side to back side. Okay, so performance on the Linoprint CV is better to plus or minus a 0.5 millimeter, kind of 12 by 18 inch sheet. Works excellent, and we even do better on the Linoprint CP.